Hey everyone, welcome back to my channel, and this is the next video wherein we are going to do an amazing question of binary tree which is called as the Morris Traversal. Well, in this video we're going to be discussing about the in-order binary tree traversal with the new approach of Morris Traversal, which we're going to be discussing in this video. I'll definitely try my level best to make the things easy for you, because I've seen so far that this topic is quite tricky and there are quite many explanations available on internet, but those are again a little bit confusing ones. So I'll definitely try to make the things easy for you, so that after watching this video you will have something out of it and you will be able to get this logic clear in a single go. So basically it's an in-order traversal. So that means there are basically two different ways in order to do the in-order traversal. One is the simple approach, wherein you can use a stack by creating it by yourself, or you can also use a recursive stack by calling the same method again and again and saving the data in the list, and basis on that you can return that particular value. But there is also an amazing and easy approach, which is the Morris Traversal, which we're going to be discussing in this video. So without wasting any time, let's get into the topic and see what exactly it is all about. So the very first thing is that that why exactly do we get to have this kind of a thing. I mean, what's the need of this Morris Traversal? Because we want to save the space, right? We don't want to create some kind of a recursive stack or some kind of a manual stack, because that when you do the in-order traversal, we know that we need to go for the left node, then we have to check for the node itself, and then we have to check towards the right hand side. So that's the reason, in order to get back to this particular place, we need to keep on having some kind of a storage, and we need to store unnecessarily some nodes, so as to go back and we can have some kind of a place, or we can have some kind of a traversal that can be done towards the right hand side. So over here as well, if you will see that when we do the in-order traversal, we'll firstly get the root node, which is 15, and after this 15 we need to go towards the left hand side. We check like whether we have any kind of a left node present or not. Then basis on that, we just keep on storing the previous value, so that we can have some kind of a reference available and we can go back and traverse back. So 15 is going to be stored over here unnecessarily, just going to be storing extra, going to be taking some extra space, and going to be having some extra space utilization over here done. Then we'll go to the night, this particular 9 number. Then we again find out that there is some kind of a left node present in it. So that's the reason we just keep some kind of a space over here. We're going to be storing this value 9, and then we will check for the number 5. Then when we reach to this number 5, we find out that 5 is not having any kind of a left node present in it. It's pointing to null. So we can just take this out, this number 5, and we can print this data. Then again we find out that this 9 is coming because of this stack over here, because we are just popping out the elements one by one. We find out that 9 is going to be the next data that we have, and it is having some kind of a right side available, because over here when we were at the 5 number, we did not find any kind of a left or right. So that's the reason we just simply pop this out number. Then we find out this 9 is having some kind of a right node available, so we keep on checking that. When we take this out, we just take this 9 out, and also going to be storing some kind of a 10 over here. So 10 is going to come into the picture, and it's going to be checked again if it is having some kind of left node available or not. Then we find out that there is nothing available. We will just simply take this out. This 10 will be taken out, and then after that we'll proceed towards, when we take this out number out, this number 10 out, then we'll just again store this number 11 back, because this is the one which is going to be available as a right side. Okay, so yeah, this is how we traverse, and 11 is again pointing to nothing, so that means 11 can also be taken out. Once everything is being taken out, we'll then go back to the number 15, which was stored initially at the very first time. So just this kind of a unnecessary space thing which has been taken, so as to do the very simple thing. Because the only thing we were worried about is that if we have some kind of a connection available from this 11 number to 15, then we would have not been taken this kind of an extra space. It is just unnecessary space taken for all the nodes, so as to just make this kind of a simple connection. And also over here as well, we were just only worried about this particular connection, that if we have some kind of a way out, that we can traverse back and we have some kind of a path available that can take us to the previous value so that we can cover up all the nodes, right? Then it's just going to be a piece of cake for us. So that is the only thing we were worried about. So for this thing, what we can do, there is a simple way out which we have, which is called as a Morris Traversal, and by which way we can get this thing done easily. So basically, when we started out with this number 15, right, there is one way which I'm going to be explaining you now, that you can just the three cases are there, just a couple of cases are there, and then it's going to be done. And it's just the flow that you need to remember so as to write the code as well. So I'll explain you this thing. So initially we were just given this root node. So we started with this particular thing and we move level by level. So firstly we're going to be going towards this particular place. This is the number 9, wherein we will be traversing very first, because we are doing the Inorder Traversal. So firstly we need to check for the left hand side. Once this is checked, we will straight away we'll create temporary node, because we find out that there is some kind of left side available. Then we will create a temporary node which is going to be called as our previous node. We can call this as anything, just I'm taking the reference over here as previous one. So we will check whether it is having any right side available or not, because that's the main concern. We just need to see if it is having some kind of a right side available so that we can make a connection back towards its previous node. That's the only thing we want to give it a check. So firstly, we check from the root node that whether it is having the left side available, and then we just go one level down. Over here we reach towards this number 9, and then we checked that whether it is having any right side available, because if it is available, then we will keep on moving towards the rightmost element from the left side. What I mean by that, we firstly go to the left side and then we check towards the rightmost node available. Once we reach towards this point, because this 11 is basically initially pointing to null, right? So this null is going to be something till the point we find out any kind of a null present on the right hand side, we keep on moving down. And once we reach towards this point, we'll break this connection, we'll remove this null from here, and we will store this particular value, which is number 15. So that's how we make the connection, right? Once this connection is made, we are done. This cycle is basically made. Then we are not worried about anything, because once the connection is made, we can traverse any single node in this particular tree. We know that we have a way back. We can go down, we can go to the next level, and there is some kind of a location or some kind of a path that we have got. So we don't really need to worry about. Okay, so that part is done. Now let's proceed further. We were at this particular position, right? Then we'll go one level down once again. And at this point, we found out two different things. One is that it's not pointing to any left side. That's the other part we don't really need to worry about. Then again, we get to note that this is pointing to null, right? This is pointing to null. Again, the similar thing is happening. As soon as we find out that the right side is equals to null, the right pointer is pointing to the null, we need to break this connection and we need to make a connection back to the current node, to the previous node, so that we can have a way back. Because just consider the fact of singly linked list. What happens in singly linked list? We keep on moving on the forward direction. We don't have any kind of a way back. Over here as well, we are moving like one by one for the Inorder Traversal, and what happens is we only have the way, we are just manually making it to moving it towards the left hand side direction, and we don't have any way back to go back to the previous node. So what we are basically doing is that as soon as we find out that the right side is equals to null, we're just making a way back. We're just making a connection back to the previous node. That's what we are doing. I hope that makes sense. And if you have any kind of a query as of now, please don't worry about it. We'll write the code, and I will definitely try my level best to explain everything that I'm going to be writing in the code with this diagram, so that you can have a clear picture in your hand. Just try to analyze the things. Just try to imagine a little bit. This is a very simple thing. This is a very simple concept. Just keep this thing in mind. As soon as we find out that the right side is equals to null, we just need to make a connection back, because we don't have any way out to go back. Over here previously, we were having a stack, and that's the reason we were able to move towards the node which we wanted to go on, and that's the reason we were able to traverse all the nodes. But over here, if you're moving towards on the left hand side, there is no way back that we can go to the node itself, or we can go to the right side. So that's the reason we are just storing out. It's not actually we are storing, we're just making a reference, and we're just making a connection manually. And how we are doing it, we will see in the coding part. All right, so let's go to the coding part now. Alright everyone, so I believe that the logic part is pretty much clear to you, and now we're going to be just writing down the code of this particular question. So it's a pretty much like, just the flow which we have to keep in our mind, and with the flow we can just write down the things easily, right? So let's start with the code. It's going to be something like it's asking us to return some kind of a list. So we're going to be creating a global list so that we can have the references stored, and basis on that we can return that. So I'm just making this list as array list. And if you have any kind of a doubt as of now with the logic, so it's gonna be pretty much get clear when I will start writing the code. Okay, so the code is also gonna be giving you the hint that how we are proceeding, because it's kind of like sometimes it is easy to just have the logic in our mind, but at the same time when we write the code, things get difficult. But don't worry about it, I'll try to explain the things quite easily over here. Okay, so the very first thing which we need to do, so this is going to be my main method. I will create a new method over here, so that I'll call this as Inorder. Okay, so let's call this as Morris itself, because that's what we are doing. So Morris is going to be taking the root, okay, and it also going to be returning the res, the result array list that we have created. So let me define this method as void, because we are not going to be having any kind of a recursion or anything like that. We're just going to be having simply void functionality. We don't want to return anything, and we're going to be doing it with some kind of an iterative approach, right? So that's the main catch over here, because we don't want to use any kind of extra space, right? Pretty much simple. So for this thing, I will be creating a new node, which is going to be my current node, and that's going to be equals to what? That's going to be equals to root itself. Okay, pretty much simple. As of now, we have just created a current node so as to store the references from the root value. So let's proceed further, and we're going to be writing the very first condition, because we're going to be doing it iteratively. So I'll create a while loop, and that's going to be done, and that's going to be executing till the point I hit null. Once null is hit, we'll find out that this is going to be the end of our binary tree, and we have traversed all the nodes that we want. And it's also going to make sure that if we have any kind of a straight away we are getting some kind of a null root, then it's going to return, it's going to break the condition and going to go back. So that's also going to be taken care, right? So that's going to also take our edge condition over here. So let's proceed further, and this time we want to give it a check, that because first of all, the very first thing which you want to give it a check is if our current dot left is equals to null or not. Okay, so basically how we are doing it, so firstly we'll check if it is equals to null. If it is equals to null, we don't want to do anything, there is nothing needs to be done. We can straight away add the value over here, res.add. That's going to store our current node itself. And next thing we want to do is we want to update the current, and that to be with what? So let me show you an example over here. The example is there in front of the screen. So you can see that this is the example, and this is the part of the code that we have written so far. You can see that from this root node, we don't have any kind of a left node present in it, right? So what do we want to do? Current dot left is equals to null. So that means we cannot do anything towards the left hand side, right? We can just store this particular value, this number 1, that to be in the array list that we have created. Once that is done, one has been traversed. Let's go towards the right hand side and do the same executions, right? That's what we want to do. Okay, so let's proceed further. And this is the very first condition, right? This is the first if condition. Just imagine for a fact, now this is the main part of the code which is going to start. This is the else condition, wherein we are going to be writing the complete code. So this is the else condition. We find out that there is some kind of a left node present from the root side. Okay, so what do we want to do? Firstly, we're going to be creating a new node that's going to call as previous, or you can call it as a temporary node. And that's again just going to be storing some kind of a references. So what reference it's going to store? It's going to store the left itself. Okay, So what happens over here, we are getting that there is some kind of a node which is present on the left hand side of the binary tree that we have, and we are calling that to be as a temporary or previous node for sake. And what we are doing, we are storing the left side reference from the current node. And what we're going to be doing with that, we want to do one thing. Like I mentioned, we're going to be, wherever we find out there is left present, we will start from that node towards its right side till we hit the bottom. So how we can do that? Till the time I find out null is present, I need to execute this while loop. And also there is also one more condition we're going to be checking over here. If previous dot write is equals to current. So I'll explain you this part in just a minute or so. But main thing is over here, the main catch that we need to keep. Let me write down the code first, then I will go back to the diagram and show you the stuff. So over here we will make previous equals previous dot write. That's what I want to do. Okay, so let's go back to the screen and see what's happening. Okay, see what is happening over here. We were at the 15, we move towards this point, right? We find out there is some kind of a right side which is present. So we'll keep on moving towards over here till the point we hit the null, and till the point we hit the bottom of this particular tree. So this is basically pointing to what? This is pointing to null. So we're going to be breaking this condition, and okay, so we'll do this later, but at the same time we just need to make sure that we traverse from this 9 till the time we reach towards this point, it is pointing to null. That's the only thing which we have done. And while loop is gonna taken care of that thing, it keep on iterating the same thing. It's gonna just passing on the reference this to this, this to this, till the point it's gonna point to the null. That's what we have written over here. Okay, I hope that makes sense and this part is clear to you. Okay, so let's proceed further. Now that we have reached towards this point, and this is gonna come out of this loop. Now again we need to check, is it actually equals to null, or is it just, you know, playing with us, right? So we will see if this is equals to null. We'll make sure that yes, it is properly equals to null, and now we can do certain part of the execution. Now what we are going to be doing, we'll be breaking this null from this 11. We'll make a connection back to this node. And what this is our current node, right? This is what we want to do. Okay, so let's proceed further. And okay, now that we have confirmed that yes, previous dot write is equals to null, and we can store this particular value to current. So we will save this to previous dot write. Okay, that part is done. And what else? As this part is done, we have made the connection, and now we can simply move one level down. Okay, so that's what we're going to be doing. Current will be equals to current dot left. That's it. That's pretty much it. This is the main crux of the whole Morris traversal, is that how we are reaching towards the bottom of the right hand side and how we are passing the reference. Once that is done, half of the code has been done. You're good to go. You're definitely, you know, understood this, but if you have understood this particular point till this point, half of the Morris traversal is done. I would say even 70% of the Morris traversal has been done. We are only left with one single condition, and that is if that is not equals to null. And what's going to happen? Just imagine for a fact why exactly it's not going to happen. You might have been thinking that we have already reached to the bottom of this particular node. Then how come it is not possible? It is not possible. There are certain cases. It's gonna happen only in that case. Just imagine for a fact you are coming back, okay? And that's how we do the Inorder Traversal, right? We go to the left bottom, then we come back to this particular point. But now this is gonna happen in the further iterations. Now that we have already made the connection, right? And once we will, you know, traverse this particular node, we'll come back to this point. We will see this connection is already been made. So that means it is not pointing to the null, it is pointing to the current node, this particular node, right? So if this is pointing to this particular point, then at that point as well, we want to come out of this while loop. And that's what has been going on. And that's where this else part is going to come into picture. Okay. So in this particular case, what do we want to do? So the very first thing is that we want to break the condition. We want to break this previous dot right equals to null. Okay. So this is where we're going to be breaking the connection, and we will adding that current node, because now that we have already traversed all the sub nodes which are present in the left hand side, we can straight away add our data. So how do we add that? We add the value. Okay. Over here as well, we need to add the value. So now the value has been added. What do we want to do next? We want to make current dot right equals current, because now that we have traversed all the nodes, right? So this has already been taken care. We have broken this particular part. We have added this node. We can go back to this particular point, right? We can move towards the right hand side of the tree. So let's do this, and yeah, that's pretty much it, guys. This is the whole code that we have written for the Morris traversal. So let's try to execute and see the test cases. I hope that's gonna work, because this is a pretty simple code. We are getting some kind of an error over here. So let's see what that error is. Okay, so this is not the point to write the void. I believe it's gonna work out for us. Okay, so there is some error that we are getting. What that is, this parenthesis is expected, and okay, so this is, you just take a look, line number 41. This is the place we are getting. Okay, we need to make this as equals. I hope that's gonna work out now. Again we are getting, okay, so we are just getting some syntax errors. That's gonna definitely work out. So I will mention one thing over here. I will, just while adding the code on the description box, I will mention all the comments, so that it will be easy for you to read the code and have some kind of a reference and everything. So let me just clear this all error that I'm getting. So I hope, what's going on, it's basically saying that it is pointing to some kind of a null. Let me just take a look. If it is equals null, previous dot right. Okay, so yeah, basically this is the error that this is the reverse thing which we have to do. If the previous dot right is equals null, then of course what do we want to do? We want to pass on this thing, right? Yeah. So if it is equals to null, then definitely we want to pass the current equals to previous dot right, and also, yeah, that makes sense. So let's try and see this, if it's gonna execute. Of course it's gonna execute, and let's try to submit this as well. So I'll do one thing, like I mentioned, I will mention every kind of a comments in the code, so that it's going to be easy for you to read through. And if you have any kind of a doubt, you can definitely put that in the comment box, so that I can have a look, and basis on that I can give you the answer back. So yeah, that's it from my side. That's it in this video. I hope you liked the video. I tried my best to explain the Morris traversal in detail, and also written the code along with the explanation. If you still have any kind of a doubt, you can put that in the comment box, and I will make a video of it if it's gonna be necessary. Otherwise, we will try and discuss the things in the comment box itself. Alright guys, so that's it from my side. Thanks for watching. See you next time.